Namaskar. Friends, in August 2016, a committee headed by former Reserve Bank of India Deputy Governor H.R. Khan had made a series of recommendations for the domestic debt market. With most of these recommendations getting implemented, the impact is beginning to show. This rapid growth of bond market in India has led to an increase in manpower which is equipped with the skills of understanding the bonds, particularly bond valuation. It is very important that we have an in-depth understanding of bond valuation because large number of jobs for our students in future will be available in this sector. To discuss the concepts of bond valuation, we have with us Dr. Kapil Sharma, who is a Faculty of Finance at Institute of Management Studies, Devi Ahalya Vishwavidyalaya, Indore. Sir, before I start with the specific focus on bond valuation, I want to ask you, how do you see the bond market in India in coming years?
Thank you, madam, for inviting me to this session. In terms of liquidity in bond market, average daily trading has almost doubled in the last 5 years, with the exception of certificate of deposits, where it is declined due to lower supply. Structurally, the debt market remains firmly skewed towards government securities, but the good part is that the domestic corporate bond market has also done fairly well in the last few years. Our banks are overstretched and overburdened with non-performing assets, and this is an opportunity for the Indian corporate bond market to further grow rapidly and offer extensive investing opportunities. By 2023, CRISIL expects corporate bond outstanding to be around rupees 55 to 60 lakh crore, which will be driven by large infrastructure investment requirements, lowering of interest rates in economy, and the inability of banks to meet up corporate lending because of their capital constraints. It is very important that budding faculty members specializing in the area of finance to have a deep understanding of bond, particularly bond valuation.
Sir, we hear a term current yield from the number of analysts and read it daily in debt market section of financial newspapers. What does it signify and why it is so important?
Current yield. It is the relationship between the current market price of the bond and its coupon payments. It represents the prevailing return that a bond is delivering to its owners. The formula for calculating current yield is annual coupon payments divided by current market price of the bond. Let us understand it with the help of an example. A bond with a face value of rupees 1000 is currently trading at rupees 950. The bond carries a coupon rate of 12% and is issued for a period of 10 years. Then the current yield of the bond will be rupees 120 divided by 950, which is 12.63%. However, if the market price of the bond is rupees 1100, then the current yield would be rupees 120 divided by 1100, which would turn out to be 10.90%. The important thing to note here is that the stated coupon rate usually remains the same during the entire life of the bond. However, the interest rate in the market fluctuates, leading to change in the market price of the bond, thus resulting into change in the current yield. As a result, investor will trade in a bond at a higher or lower price until the current yield of that bond is equivalent to the current yield of securities with similar risk profiles. Though it is very simplistic measure, but it does not consider the capital gain or loss if realized by the bondholder in case he holds the bond till its maturity. Moreover, it ignores the time value of money.
Sir, what do you mean by yield to maturity? How it is used in analyzing the performance of a bond?
When it comes to yield to maturity, or YTM as we call, is a very important measure for analyzing a bond's performance. We know that the three basic characteristics of a bond, that is face value, coupon rate and time, do not change with the environment. But due to economic environment, market price of bond can change. Suppose a bond has a face value of rupees 1000 with a coupon payment of rupees 120 during a year, then the coupon rate is 12%. This 12% can be considered as the rate of return or yield from the bond, but it is purely based upon face value and ignores time value of coupon payments and redemption price. Hence, it is better to consider discounted value of coupon payments received at different time points and the discounted value of redemption price received at the time of maturity. Hence, YTM is the discount rate that makes the present value of cash inflows from the bond equal to the cash outflows done for purchasing the bond. In other words, it is the IRR earned from a bond if it is held till maturity. I will explain this using an example. Let us take a bond with a face value of rupees 1000 having a tenure of 2 years and a coupon rate of 5% annually. The bond is available at rupees 946.93 in secondary market. An investor pays rupees 946.93 to acquire the bond and intends to hold it till maturity. The bond holder is entitled for rupees 50 at the end of the first year and rupees 50 plus rupees 1000 at the end of the second year. To find out the YTM of the bond, we need to calculate the rate which the present value of cash outflow and the purchase price of the bond is equal to the present value of cash inflow, that is coupon payments for the 2 years and redemption value. Therefore, we have the equation 946.63 is equal to 50 plus 1050, that is divided by the discounting rates, and with the help of that we get the value of 7.99%, which is the YTM of the bond.
Sir, people often find difficulty in determining the right price of a bond which they should pay in order to acquire it. So, how does one calculate the right prices of a bond?
It is a very common problem. The technical term used for the right price of the bond is intrinsic. In case of bond, the present value of its future payments is taken in to be its intrinsic value. But for determining the present value, an important step is selection of a suitable discount rate, which is a tedious task. We have already discussed the concept of YTM. For calculating value of bond, what we need is an indicative YTM. Now, the indicative YTMs can be obtained from the prices at which bonds of different maturities are purchased or sold in the primary or secondary bond market. Once we have YTMs of bonds with different maturity periods, we can plot a graph with the time to maturities on the x axis and their corresponding YTMs on the y axis. As indicated in the graph on the screen, such a graph is usually referred as yield curve. The yield curve gives YTMs of the bond for different times to maturity. Using the appropriate YTM obtained from the yield curve, we can calculate the intrinsic value of a bond.
Sir, for calculating value of a bond, we use yield curve to arrive at an appropriate discount rate or YTM. Please throw some light on how is the value of bond related to YTM.
As far as the relationship between value of bond and YTM is concerned, they are inversely proportional to each other, which means that if YTM increases, value of bond will decrease and vice versa. Let me explain this with the help of an example. Let us consider a bond with a face value of rupees 1000 having a coupon rate of 12%, where payments are made semi-annually and the term to maturity is 8 years. Let the indicative YTM for such a bond in the market be 13%. Then the value of bond arrived after calculation will be 951.16. Using 13% as an indicative YTM, the value of bond is rupees 951.16. Now let us find the value of bond by changing the YTMs. Now let us find the value of bond by changing the YTMs. As you can see on the screen, that the value of bond decreases as YTM increases. For example, at 12.5% YTM, value of bond is 975.16. At a YTM of 13.5%, the value is 927.96 and so on. Since YTM is the denominator, the value of the bond increases when YTM decreases and value decreases when YTM increases. An interesting thing to note is that an increase in price for a given level of decrease in YTM is less than the decrease in price for the same level of increase in YTM.
Sir, it is observed that bonds trade at premium and discount. How both coupon rate and YTM affect a bond's premium or discount?
Whether a bond is at premium or discount depends upon the relationship between the coupon rate of the bond and its YTM. Let us consider a bond having face value of rupees 1000 maturing after 5 years with a coupon rate of 10% paid semi-annually. We can see in the table as depicted on the screen how the price of a bond changes as YTM varies. At a face value of rupees 1000 with a coupon rate of 10% and YTM 8%, we see that the bond is at a premium of rupees 81.11. But when the YTM is 12% and coupon rate is 10%, bond is at a discount of rupees 73.60. When both YTM and coupon rate are same, that is 10%, the bond sells at par. From these calculations, we can infer that when YTM is greater than coupon rate, that is YTM is 12% and coupon rate is 10%, bond is at discount. Whereas when YTM is less than coupon rate, that is YTM is 8% and coupon rate is 10%, bond is at a premium. When YTM is equal to coupon rate, that is both at 10%, bond is at par.
Sir, having understood the effect of coupon rate and YTM on the discount and premium aspect of bond, I wish to know, is there any effect of term to maturity also when it comes to bond prices?
Yes, indeed, term to maturity does affect the value of bond. If we assume that YTM will remain constant during the term to maturity, then there are two types of effects to term to maturity on the value of bond, and they are: first, the size of premium or discount decreases as the bond approaches its maturity, and second is the size of premium of discount decreases as an increase in the rate as bond approaches its maturity. I will take the example of a 5-year bond with the face value of rupees 1000 and coupon rate of 14% paid semi-annually. Let YTM of the bond be 13.5. For the entire term of the bond, now let us see how the price of the bond changes with the change in the term to maturity. I will take the example of a 5-year bond with a face value of rupees 1000 and coupon rate of 14% paid semi-annually. Let YTM of bond be 13.5% for the entire term of bond. Let us see on the screen how the price of the bond changes with the change in the term to maturity. From the calculations depicted on the screen, we can infer that as the term to maturity reduces from 5 to 4 years, there is a reduction in premium by rupees 2.69, which goes further from 4 to 3 years and so on. From these calculations, we can infer that as the term to maturity reduces from 5 to 4, there is a reduction in the premium by rupees 2.69, which goes further from 4 to 3 and so on. Moreover, this decrease is at increasing rate as term to maturity reduces. Similarly, the phenomena can be observed in case of discounts also.
Sir, there are many companies which issue bonds with an option to call back or repurchases them before their term to maturity. How do we calculate yield for such types of bonds?
The yield on such type of bonds is called yield to call or YTC. The method for YTC is very much similar to calculating YTM with some changes. One thing is to be noted that the call period is different from the maturity period and the call value could be different from the maturity value. Let me take an example. Suppose a bond with a face value of rupees 1000 bearing a coupon rate of 10% per annum and a tenure of 10 years has a call option at the end of 5th year with redemption value of rupees 1050. Currently, the bond is selling for rupees 950 in the market. An investor purchases it. Now, to calculate yield to call, we can assume x to be the value of yield to call, and using the same formula as we used for YTM, we will find yield to call. That turns out to be 12.7%. Now, if we calculate YTM for the same bond, assuming the same redemption value of rupees 1050, but tenure of 10 years, we will get 10.9% as YTM.
Dr. Sharma, a term comes again and again when we read any articles or research papers on bonds, and that term is duration of a bond. What exactly do we mean by it and what does it measure?
The concept of duration is very important as it deals with the risk associated with the bond. We all know that bond prices are affected by changes in interest rates in the market and economy. Duration is a measure of bonds sensitivity to interest rate changes. It is an approximate measure of bonds price sensitivity to changes in the interest rates. The measure of duration is in time, that is in years, months or days. Let us say if a bond has a duration of 5 years and interest rate increase by 1%, the bond price will drop approximately 5%. Likewise, if rates fall by 1%, the same bond price will increase by about 5%. Further, duration gives a measure of the extent of changes that would incur in the value of a bond for a given change in its YTM. Mathematically, duration is the weighted average of lengths of time until the remaining payments are made. The formula for Macaulay's duration, as you can see on the screen, duration is represented by capital D and the formula is summation PV into CT multiplied by small t plus PV into FV multiplied by capital T whole divided by summation PVCT plus PVFV, where T represents term to maturity, small t represents time points at which different coupon payments are made, CT represents coupon payments at in time intervals, FV represents face value and PV stands for present value. To understand the formula, let us take an example and calculate duration of a bond maturing after 3 years with face value of rupees 1000 and yearly coupon payments of rupees 80. Let us assume that YTM is 10%, then duration can be calculated as appearing on the screen. What we see on the screen is that the sum of present value of cash flows is rupees 950.27 and sum of product of time of cash flow and present value of cash flow is rupees 2639.23. Now using the formula for duration as discussed and putting values in the formula, duration turns out to be 2.78 years, that is 2639.23 divided by 950.27. The higher the bond's duration, the greater its sensitivity to changes in interest rates and vice versa. In a nutshell, duration measures the level of interest rate risk of a bond.
Sir, there is another term that is often used along with duration, and that is convexity. What is it and what is its significance?
Like duration, convexity is another important concept when it comes to bond valuation. Technically speaking, a bond's convexity measures its sensitivity of bond's duration due to changes in yield. In other words, it measures the degree of non-linear relationship between the bond price and yield of a bond. See what happens theoretically. Duration indicates that change in bond price is linear in nature, but in fact it exhibits a convex shape. A bond is said to have positive convexity if duration rises as the yield declines. Such bonds will have larger price increase due to decline in yield than price declines due to increase in yields. Similarly, bonds can have negative convexity, which would indicate that duration rises as yield increases, and this can work against an investor's interest. Let us look at this figure where on x axis we have bond yield and y axis we have bond prices. From this we can infer that bond A has a higher convexity than bond B, which indicates that other factors being equal, bond A will always have a higher price change than bond B as interest rates rise or fall.
Sir, there are many investors, particularly elderly people, who look for a constant stream of income and create bond portfolio. But interest rate changes in economy are beyond investors' control, and how can such investors protect their bond portfolio by the adverse changes in interest rates?
Look, the strategy to protect a bond portfolio from adverse changes in interest rates is called immunization. A bond is said to be immunized if it is not affected by the adverse changes in the interest rates. To immunize the bond portfolio, one must know the duration of a bond in the portfolio, as bond immunization strategy attempts to minimize the interest rate risk of a bond. Investors, by adjusting the portfolio duration to match with the investor's time horizon, by doing so, immunization looks in a fixed rate of return during the amount of time an investor plans to keep his bond without encashing it. Let us assume an investor needs rupees 10,000 rupees at the end of 5th year. To immunize against this definite cash outflow, the investor can purchase a 5-year zero coupon bond with a redemption value of rupees 10,000. However, there are difficulties in immunization. The bond portfolio, such as it is necessary to rebalance the portfolio from time to time, since the duration depends upon yield and yield can keep on changing. Moreover, the immunization method assumes that all yields are equal, which is not quite realistic, that bonds with different maturities have the same yield.
So, with this, we come to an end to the session on bond valuation. I thank Dr. Kapil Sharma, sir, for insights on this valuable topic.